Okay, good morning, everybody. It's a pleasure to see so many familiar faces. With some of you, I go back a long time, and we just calculated that together I'm going back with you more than 1,000 years. So it's really a pleasure to see so many faces from the past and from the present. I think we have a very nice program today. So I'll kick off by just a short introduction, and more specifically, I'll give you a 10 minutes rundown of my life. So I'll start with that right away. So starting with the early days. So that's me here, and I don't know if you can guess which one of these ones is me. That one? Yeah, that was required those days. Okay, so that was actually in Germany. So in northern Germany, come from northern Germany, from the Dutch border actually, and from a town called Lingen. And then my family moved to here and then to Hannover, where I grew up and went to high school. Then actually I went from here to Los Angeles for 1 year as an exchange student many years ago. And then I finished here, and sometimes students ask me whether I was always very diligent student and so on, but that was not the case in high school. But then I started here to study in Göttingen, and then I became quite ambitious. And so this is Gänseliesel in Göttingen. So when you study there and you get your PhD, you're supposed to kiss the Gänseliesel, which can be a problem in the winter. So, but I actually didn't stay here for, so I should say first that I went actually to Max Planck Institute for this master's thesis. So master's thesis at that time was 2 years. So that was quite good at the Max Planck Institute, and I thought this is how science is done at the Max Planck Institute, but I was badly mistaken. So then it took me like 20 years to get to that same level of what I had as a master's student in terms of equipment and so on. So Peter Tönnies is, some say, the best experimental physicist in Germany, and a little known fact that he's American and he came to Germany because of Wolfgang Paul, because he wanted to use this new technology. So the new technology was the quadrupole and the ion trap. So I have a direct lineage to the quadrupole and the ion trap. And you'll hear the successors to this this afternoon, or this morning also. So so that was Göttingen. But then, actually this is also talking about birthdays. This is fun. So because like 2 weeks ago, he sent this email around. So he's still active. We see him at the section meetings as a Max Planck director. And he's saying here that he's turning 90 and he still has his group and he wants to have this new reunion. So I'm already saying now, if I forget later, I'll also invite you to my 90th reunion. Hope to see all of you. Okay, so then John Fenn came actually to this institute in Max Planck. He got a fellowship and he worked with me. I was assigned to him, and then he said, it's boring for you to stay here and do your PhD. Why don't you come with me to Yale? And then I said, and I looked up in the library, where's this Yale thing? And it was between New York and Boston, so that sounded fun. And then I said, I will go there. So I went to Mason Lab, and that's also a fun thing at Yale, because John Fenn was in the basement here, on the first floor, and on the second floor was Csaba Horvath, and Csaba Horvath is the inventor actually of the packed column. So they were both together, but they didn't work together, but there were other personal connections between the groups. So that was here, and then that was actually a photo I made when I came. I was assigned to this Electrospray project, and this is sort of I sometimes say I'm a one-trick pony. I've stuck with Electrospray all my life, and I intend to stick with it for the rest as well. So we studied. I was assigned to study, how does this beam form and different forms. And then this is a group. It was very small. So they wanted to actually kick out John Fenn because that time he was over 65 and he couldn't stay, but he found all kinds of ways not to be kicked out. But the group was very small and never got any grants. So, and this is a group, and this one is actually not part of the group. She was just there because I got to know what I thought was a Swedish girl elsewhere on the campus, and that was then the reason for this back and forth to Denmark. So this is actually the group some years later. So same Danish girl here, and this was for the occasion of the Nobel Prize. So then John Fenn got the Nobel Prize for this weird invention of the electrospray, and he was just a fantastic mentor. If you want to read a bit more about him, then I've written an obituary for him a number of years ago. So that was the electrospray, and also it's the 30th birthday for the electrospray, at least it's coming out for the large molecules. And that there was just actually Alexander Makarov and myself were asked to write about the electrospray and the Orbitrap. And you'll hear from Alexander this afternoon, 20-year anniversary of the Orbitrap. And here I've written about how this unlikely invention of the electrospray and how that came about. So then, due to the Danish girl, I then went to Odense, which is in Denmark, and there I was actually, so I've been fortunate in my entire career that I was very privileged to have all the equipment I needed, I would say, except for Yale, because we didn't have any money, and except for Odense, where we also didn't have any money initially. But it was very good in other ways because that forced me to do something completely different. Then I started to program, and that's where that came from. So so we did a lot of good things, and Ole Vorm, who is here, I met him there, and he built a mass spectrometer, a MALDI mass spectrometer, and I wrote the software for it. So that's how we got together, and you'll hear from him. So then from Odense, after 3 years, I got sort of my break out here to be a group leader at EMBL, which was fantastic. And there we really wanted to show that mass spectrometry could do something, because after all these years, people talking, that mass spec could do something in biology, but nothing happened. And then we really want to say, okay, we can discover proteins with new proteins, new genes with mass spectrometry. So so that was both the most stressful time of my life, but also the most successful, I would say. And we came up with this nano-electrospray, so which made it very sensitive. And then so that was Matthias Wilm, and then Andrei Shevchenko had this sample preparation method, which is still the most cited paper, almost 10,000 citations. And I wrote the software to find peptides in the new databases that were coming along. And with that, then actually, so we published this in 1996 in Nature, and then a year later, there were actually 10 papers in Cell Science in Nature from EMBL people to using this and finding new proteins such as telomerase and what have you. So a lot of the famous molecules were actually found by mass spectrometry in this way. So then there was another, it's actually one of the speakers today, another family thing. So that got me back to Denmark. And so then I went back to Denmark, but a bit better circumstances. And there we did a lot of things. And we, at that time, so I'd met Angus Lamond at the time at EMBL, but then we continued working, and he really seduced me to go into cell biology and the other way around into proteomics. And this is the nucleolus. So we worked on the nucleolus and got an inventory of the nucleolus, for instance. So I was still in Denmark, and that was the time I I was then transitioning to here, and that's that transition from Odense to Munich, because I got the position here 14 years ago, and since then we have been always working on this workflow and making it robust and fast and so on, as you will hear all through today. And then the last 5 years we've really focused very much to bring it into the clinics, and I want to do that for the rest of my career as well. And that was enabled by a grant. So this is a grant that we wrote in 2015 for the Novo Nordisk Foundation, and they gave us the equivalent of 9 million euros to start this, and that was then the start of my group in. So this is the blood was already known from the ancient Greeks to be somehow important in health, and finally we should do this now with mass spectrometry. So since then I've had a group in Copenhagen here, so where my wife lives also, and then I have a group here in Copenhagen and in Munich, and I will actually say in our closing remarks today how that's working out for the future. Okay, so then I have to say thanks to all these groups over the years. It was really fantastic. So my wife complains that that's actually sort of my first family always, the group, but really it's been very good. And also I want to give a shout out to the companies, because over the years we've worked very closely with the companies, and without them we couldn't do this, and also without them the things we develop would not get out to the public, right? So it's been mutually very beneficial, and we worked a lot with BUCA, both at EMBL with the MALDI, and now again, as you will hear, with Thermo a lot, and Evosep, that's one of oldest companies, and then this was coming out of the group here, and Pharmafluidics. So we are working with these companies a lot, and that's been also very good and essential. So that's what I want to say about my CV. And then today the theme is going into the clinic with this, and can it be clinically useful, this technology, after all these years. And we'll hear from Albert, who's actually also our SAB, head of SAB, that we had evaluation the last 2 days. Brenda, my new colleague that we also work very closely with. Then from my group, you'll hear about how these esoteric, perhaps, mass spec technologies can actually lead now to value in Parkinson's disease. Ola already mentioned him. So they also have, that's their mission, to bring this into the clinic. Angus, and he's now into IP cells and doing this together with the large genome resources. And then in the afternoon, Frank Laukien, who we now work with, will tell you actually about the first example where proteomics is actually really used in the clinic, in the biotyper, and also what we do together with them now. Maiken from Harvard, epidemiology, that's becoming very important if you get large data sets. And she's transitioning to Copenhagen actually, and Nikolai from Copenhagen group also bring this into both diabetes research and into the clinic. Philip's been spearheading the plasma proteome, and him you already saw in the picture. So he's going to talk about ethical aspects. And then here, this is especially dear to my heart. It's the software development, so we're restarting that in my group. Then you hear from Matthias Chöp, who is how this could be important for diabetes and why diabetes research is important in the first place. Alexander already told you about the Orbitrap, and then Rudi Ebersold, and I'll here reveal the plans for the future. Okay, so that's nice day.